All right. So where we left off said part two. What is this point slope formula for the previous problem in slope intercept form? Now, again, to show you that the previous answer, I got two different answers, right? But it didn't really matter because I'm going to show you here how both of those are actually going to lead to the same y equals formula or slope intercept, right? So the first thing we want to do is, all right, notice how we went from point slope, y minus y1 equals mx minus x1. Now, we're trying to get to, let me see, all right, we're trying to get into y equals mx plus b. Now, unfortunately, we just can't substitute information, right? Like, yes, we can plug in the m for 1/3, negative 1/3, but it is really difficult for us to find the b, right? So our best option here is to just work from this and convert it into this, right? So the first thing I want you to notice is the fact that, hey, notice how there's parentheses in point slope, but there isn't parentheses in slope intercept form. Okay, that is the first major thing that I want you to notice. So going back to the second week of school, what do we do when we have parentheses? We distribute, right? And again, notice I'm going to do this 2 times to show you that both of these answers are correct, all right? So here, I'm going to distribute. So I'll rewrite the problem here for you. Y minus 8 equals a negative 1/3 x plus 12. Now again, I'm going to distribute this negative 1/3. Why? Because we have parentheses. Now I'm going to do both of these simultaneously just so again, you can see that both of these are going to give me the same thing. Why? Because both of these equations are the same equation. We just used different points. This one had 6, 2 as a starting point. This one had negative 12, positive 8, right? As we saw earlier, right here. 6, 2, negative 12, 8. But they are the same equation nonetheless, right? So going here, all right, so the first thing we said was, well, we distribute. We have a number outside of parentheses. So I get y minus 8 equals negative 1/3 times x is a negative 1/3 x. Negative 1/3 times a positive 12 is a negative 4. Be very careful. Please use your calculator. Don't get it wrong because you are assuming you're multiplying correctly. Please use your calculators. Same thing here. We're distributing the negative 1/3. Again, because this has parentheses, the form we want to get it to does not. So I distribute. So I get y minus 2 equals negative 1/3 times x is a negative 1/3 x. Negative 1/3 times a negative 6 gives me a positive 2. Okay, now, again, notice how that was actually pretty good. Notice how now this looks like, oh, wait a minute, look, it's looking like mx plus b. We're almost getting there, right? Mx plus b. But again, don't be fooled. What is special about slope intercept? Oh, it's y equals. So what do we do here to get this y by itself? Oh, I'm going to add 8. Again, I need to get y by itself. I need to get rid of the constant. So on the left side, I got y. Now look, this negative 1/3 was not changed because the 8 does not get added to the variable. It gets added to the constant. 8 minus 4 is a positive 4. Now look at the right side. Again, same thing. I want y equals. This actually has y minus 2. How do I get rid of this negative 2? I add 2 to both sides. Again, why? Because I need to get y by itself. 2 minus 2 cancels. Again, this negative 1/3 x stayed the same because I added a constant. The 2 is adding to the constants. What is 2 plus 2? 4. OMG. So again, what does that mean? This means that both of these equations on top are the same thing, right? We just used different starting points. It had a 6 and a 2 as a starting point. This was a negative 12 and a positive 8. But again, when it comes to changing this to slope intercept, of course these had to be the same because look, they had to have the same y-intercept, which happened to be 4. Yes, yes. So again, you can only do one of them. You don't have to do both sides. This is just practice for you. And I wanted you to see it, that it doesn't matter what point you use, you should still be able to get the same and the correct equation, right? So in slope-intercept, I get y equals negative 1/3 x plus 4. So again, y equals negative 1/3 x plus 4. All right, all right. Let's go to problem number 5. Problem number 5. All right, so here it says model the data in the table with the linear equation. So they're already telling me it's linear. So I know I'm going to have either y equals mx plus b or a point slope. Now, then tell what the slope and y-intercept represent. All right, so looking at here, what is the equation and slope-intercept? Well, we just did this. Can I write an equation in slope-intercept? Well, yes, but here I don't have my y-intercept. I don't have x is equal to 0. Now, can some of you guys figure this out on your own? Yes, but I'm not going to do it that way because, again, we're practicing point slope. So in this case, I'm going to solve this using point slope. So, again, looking at the nice thing about this, we are given a nice table. X and Y. I'm going to write down the first 2 points, 1 and 9, 3 and 27. And I'm going to write, actually, that's all I need, right? Now, again, they want it in slope-intercept. It'll take me a few steps to get there, but I'm going to do this. So, again, we're given our table. If you guys remember, first thing I have to do, I can't write this in y equals mx plus b because I have my y-intercept. Remember, y-intercept is when x is equal to 0. I don't have that here. I only get when x is 1, 3, and so forth. So the next thing I have to do is use my point slope. So do I have a point given to me? Yeah, I actually have 2. So I can use whichever one. But the thing that we're missing is slope. Well, how do we find slope? Well, the nice thing about this, remember, actually, given a table, I just do the change in y with the change in x. Remember, this is the nice thing about a table. We pick a direction. I'm going to go down the table. So how do I get from 9 to 27? Oh, I added 18. How do I get from 1 to 3? Oh, I added 2. You see that? So here, my change in y was a positive 18. My change in x was a positive 2. 18 divided by 2 gives me 9. So just like that, I found my slope. Hey, not bad, right? So look, now I have everything that I need. Y minus, I'm going to use the 0.19 here only because the numbers are smaller and they're both positive, which means I don't have to change anything. All right, so y minus y1 here is a 9 equals my m, which is 9, x minus, and what is my x1 here? My x1 is 1. So I get y minus 9 equals 9 x minus 1. Now remember, again, I know some of you guys are probably going to figure this out a different way and a lot faster. But again, I'm just showing you for the practice purposes. So here, I have it in point slope, but they wanted a slope intercept, as you can clearly see on the homework. All right, look, slope intercept, y equals. So look it over here. All right, well, the first thing we did was distribute. So I get y minus 9 equals 9 times x is 9x. 9 times a negative 1 is a negative 9. How do I get 9 by itself? I'm sorry, how do I get y by itself? I add 9. I got to get rid of this constant. Well, 9 minus 9 cancels, so I'm left with y equals my 9x was not changed. Again, notice how that's a coefficient with the variable. That was not changed at all. 9 minus 9 is 0. Do I need to put the plus 0? No. Can you put it? Yes, but again, for all intents and purposes, we leave out the plus 0 because it's nothing. So my equation is y equals 9x. Just like that. Now again, for those of you that are being cautious, you actually could have done this using 3, 2. This is actually a direct variation problem, right? But again, that's if you did that part and you actually understood it. But now, don't worry about it. You can always just do it this way. Next, it says, what does the slope represent? Well, slope is the change in y over the change in x? Well, it is the amount of wages earned for the number of hours worked. So it's your pay in hours per dollar. It's your pay in dollars per hour. It's the rate of pay, right? This is the amount of money we're earning based on the number of work. Pay in dollars per hour. Dollars per hour. Going back over here, right? You want to get technical? Y here was money. So it's $18 over X is hours. So it's dollars per, meaning division, hour. There it is. So my slope represents pay in dollars per hour. And what does the y-intercept represent? Well, going back to our equation and looking at here, well, what's happening? You're getting paid $9 an hour. So what does the y-intercept represent? Well, if you look at our problem here, well, the y-intercept was 0, right? And what's also special about the y-intercept is when x is 0, right? It's right here. The y-intercept is when x is 0. So what does it mean? Well, if you're working 0 hours, how much are you going to get paid? $0. So it's the initial time worked in hours, final time, initial wages earned in dollars. The y represents the amount of money that you started earning, right? Because it's y, right? There it is. How much time we have left here? Ooh, perfect. All right, we're going back to the beginning. They want us to graph a line with the given point and slope. Fairly easy problem here. Oh. So again, I'm given the point 3, 5, and I'm given a slope of negative 1/5. So remember, we have 2 parts here. Oh, they just wanted to graph. So we didn't have to even write the equation. We can actually just graph the point straight out, right? This is my point. Actually, no, I'm going to show you just to be sure. So again, here, the slope, the part that we have to be careful with is this, the slope. I really hope you guys are being cautious and understanding this, right? So remember, slope is rise over run, right? So, you guys can't see that. There we go. It's rise over run, right? Now remember, it's always triangles. In this case, we're starting at a point, which is 3, 5. I'm not going to graph it here for you because we don't really need to do that right now. What I'm trying to get you to see is that slope is always a triangle. Notice how here, my rise is a negative 1. So this means that I'm going down 1 unit. See, notice how I went down. Now, what is my run? My run is a positive 5. So this means I'm going to jump 5 spaces. 1, 2, 3, 4, 5. See, so again, notice how here we can end up with our 2 points. This one and this one. 1, 2, 3, 4, 5. So again, the slope, this is the triangle they always end up with. Notice how we always start with rise and then the run. So here, this was the 0.35, which probably would have been this one. But again, we don't really need to write the equation. All we need to know is be able to how to graph this. So let's go to the 0.35. 3, 5, which is right here. Again, notice how we can verify it using the coordinates points here. Now again, notice how this triangle kind of told me what I need to do. I go down 1 unit because my rise is negative 1, and I run 5 to the right because it's positive. Again, down 1, right 5. Minus 1 plus 5. Be very careful, guys. So here, I'm going down 1 over 1, 2, 3, 4, 5. Ka-chow. Check it. You're done. All right. Easy as pie. Again, if you need to slow down the video, please. But make sure you guys are taking your time and doing what you have to. Take care.